So what I'm going to do now is I'm going to show you how you express a complex number in what's called ModArg form. So mod stands for modulus and arg stands for argument. So when a complex number is written as x plus iy, this is its rectangular form. So it has coordinates of x and y. We've seen how to graph that on the complex number plane. But we can also express them in polar coordinates, which is of the form r and theta, where r is the distance it is away from the origin and theta is the angle that the line makes with the positive x-axis. So if we have a look at our complex number over here, so let's say this is x plus iy, we can see here we've got a distance it is away from the origin. We also have an angle that it makes with a positive x-axis. So this is what's called its argument. Now a few things about modulus and argument. So the way the modulus is written, it was written as the modulus of z, so it would be the absolute value signs effectively around z. Now if we have a look at our diagram over here, we can see we've got a right angled triangle. So this distance is x and this distance up here is a y. So that means this distance here, using Pythagoras, is square root of x squared plus y squared. The argument, this angle here, we know we can get from looking at that distance and that distance. So it's actually tan theta is equal to opposite over adjacent, which is y on x. So using those two bits of information, we can express a complex number in polar form. Now a few things about modulus and argument. Modulus has to be greater than 0. So r has to be greater than 0, or the modulus has to be greater than 0. Because if it's not greater than 0, then you don't have a complex number, it'd just be the origin. Argument is always expressed as either from there all the way around to here. So the argument of z, we write arg, less than or equal to 180, or all the way around here, but not including negative 180. So if it sits on the line over here on the axis, then we'd call it 180 degrees. We don't get confused about which one to do it as. So if we've got a complex number x plus iy, we know we can write x, so this distance here is going to be r times cos theta. So we have r cos theta plus the y value is r sine theta. So x we can write as cos theta, and you're familiar with that from your other work, and y is expressed as sine theta. Now that has an I as well. Now what we can do is we can take a factor of r out from here, so we get r cos theta plus I sine theta. We generally put the I in front of the sign. Now that's what's called ModArg form. Now we can simplify that a little bit, and this is the way it's written. So it's often written as r cis theta. So that's a CIS. So when you see r cis theta, it's the same as this. We've just taken out the brackets, we've replaced the cos with a C, we've replaced the I sine with IS.